Hey guys, round 2 here. So if you watched the first video, there was a quick overview of all of the exponential rules and little things that people forget all the time. And then here we're going to look at solving actual exponential equations. So we'll do a few examples together. I have some Khan Academy for you guys to practice today, and then our short Schoology quizzes afterwards. Okay, so one thing that you have to remember about this is we want to use a lot of those bases, those smaller bases, to rewrite our problems with. So here I have 8 equals 2 to the x power. And I'm trying to solve for x, but that's an exponent. So I have to think 2 to what power would give me 8? Well, it's a lot easier if I rewrite them with the same base. And while this is a pretty basic one, this tip will help you with some more complex ones, okay? Well, I know that 8 is written as 2 to the third power, and 2 cannot be made into any smaller of a base. So if I rewrite 8 as 2 to the third, 2 to the third power is equal to 2 to the x. That's what it says now. Well, if the bases are equivalent, 2 and 2, that means that the exponents have to be equivalent. So that tells me that 3 is equal to x. Right? Simple as that. Now, we sort of knew that before. 2 to the third power is equal to 8, so x has to be 3. But making the bases of the same, you can almost ignore the fact that you have those 2's there, and then just look at the equation you have left. X is equal to 3. Bring those exponents down, okay? Let's try another one. So this is 26 to the 9x plus 5 power. That's all one piece, is equal to 1. So if I'm going to rewrite this with the same base, well, 26, there's really nothing to a power that gives us 26. So I'm kind of stuck there. But I know anything to the 0th power can give me 1. So let's say I rewrite this as 26 to the 9x plus 5 is equal to 26 to the 0th power. Right? Now they have the same base, so I can ignore those and just set my exponents equal to each other. Now I am just responsible for solving this small equation for x. So x would be equal to negative 5/9. So if I put negative 5/9 in for x, let's check it. Oops. Oh no, that was right. Plus 5 is equal to 1. So 9 times negative 5/9. The 9's would cancel and give me negative 5 plus 5. Negative 5 plus 5 is 0. So I get 26 to the 0th power is equal to 1. Hey, that's a true statement, right? So anytime you have a 1 there, rewrite it with the same base as on the other side, but to a power of 0. Let's try another, again, a little trickier here. So, we have 2 to the 3x plus 5 power and 64 to the x minus 7 power. So I'm trying to think about making them the same base. Well, 2 is a small prime number, and we can't really go any lower than 2. So we have to think about 64, rewriting 64 as 2 to the something power, right? So if you remember from before, we did all the powers of 2. 2 to the 5th was 32, and 2 to the 6th gave me 64. So I'm going to rewrite this as 2 to the 3x plus 5. And then I'm rewriting 64 as 2 to the 6th to the x minus 7. Okay? So think back to your exponent rules. What do I do when I have a power raised to another power? Well, I need to multiply them. And so that really means I'm distributing. And because the bases are now the same, we have 2 here and 2 here, I'm just going to set the exponents equal to each other. Excuse me. So 3x plus 5 would be equal to 6 times x minus 7. Now you're just responsible for solving this equation, which is basic algebra 1 stuff, right? So distribute, so 3x plus 5 is equal to 6x minus 42. Take that away. Take away 5 from both sides. Negative 3x is equal to negative 47. Divide by negative 3. And we get x should be 47 thirds. Okay. So really think about what we just did here. First step is to look at what your bases are and to make them the same value. We know that we can't turn 2 into 6, well, we could turn 2 into 64, I guess, but that seems harder. We always want to go to the lower base, okay? So what I'm going to do here is take this higher value, 64, and rewrite it with a smaller base, which was 2 to the 6th. So now I get the left side unchanged, and the right side becoming 2 to the 6th to the x minus 7, right? And then power to a power tells us to multiply. So then I'm just setting those exponents equal to each other, which is what we have here. All right. So they can get a little tricky, but you're really just thinking about rewriting them with the same base and then setting exponents equal to each other. Let's try one where we have to change both bases. So this is 32 to the x over 3 power, and this is 8 to the x minus 12 power. So here, we have to change both bases to be a smaller value. Well, I know 32 can be written as 2 to the 5th, and I know 8 can be written as 2 to the 3rd. Oops. So what we're going to do here is rewrite both of these. 2 to the 5th for 32, and then it's raised to the x over 3 power. 2 to the 3rd for 8, raised to the x minus 12 power. So when we have a power to a power, then we're going to multiply. So it becomes 2 to the 5, and treat this like 5 over 1, right? So we're multiplying straight across. 5x over 3 power. And over here, this is 2 to the 3 times x minus 12 power, right? So we're multiplying those exponents there and we have power to a power. When the bases are the same, we're just going to bring down the exponents and set them equal. So 5x over 3 is equal to 3x minus 36. Multiply both sides by 3. 5x is equal to 9x minus, oh goodness, 90 and 108, minus 108. So negative 4x equals negative 108. Divide by negative 4, and then x is whatever 108 divided by 4 is. 27. So same process for all these problems. Make the bases the same, set the exponents equal, but some can get a little trickier than others. All right. So go ahead and try the Khan Academy practice, and then try the 3 questions.